Hello. So, welcome to this video on our Tasca School YouTube channel. And today's Wednesday, so we are talking about science and we're doing science experiments. This week, we have been talking about the relationship between humans and the ocean. And of course, you guys mentioned something very important, which are submarines. Now, that got me thinking, how do they float and how do they sink? Submarines are a means of transport that, I don't know if you knew that, but they have the shape of a whale, okay? And it's meant to be on purpose so that they are aerodynamic and they can move better in deep waters. Now, submarines can sink very, very deep, but they also can float. So, how do they do that? How can they sink and how can they float? How can they float? I don't know if you remember that one time we did an experiment about objects that would sink and objects that would float, and we didn't find one object that could do both. Now, that got me thinking and that got me researching, and I found a very cool experiment that explains how this works. So, it turns out that submarines are led by something that is called the Archimedes principle, in which they change the volume of density inside the submarine, the volume of air, so that it will sink or float according to as needed. Let's see what happens with the following experiment. Okay, you're going to need a big jar with water. It doesn't have to be full with water, but just as much so we can see if it sinks or float. We're rather a jar that has a big mouth so we can put the stuff inside. We also need a bottle. It can be any bottle you have. It can be a soda bottle, a juice bottle. It just has to be plastic and you have to have the lid on. Mine is a ketchup bottle. Good. We also need a key. We also need a syringe without the needle. We need some coins. You're also going to need a cork, a wine cork, and a ketchup envelope. I don't know if it's an envelope. It's a little ketchup. And anything you may have to put it together. It can be a string, an elastic band. Mine are the ones you usually find with food, and you can fold them. So the first experiment is with a big jar and a cork. What do you think is going to happen if I put this wine cork in the jar of water? Will it sink or will it float? Let's see what happens. It floats. And of course we knew this because as we have done experiments before with this, we know and we understand that the density of this wine cork is way less than the density of the water. So of course it's going to float. But what happens if we tie to the cork a key? Here it is. I have tied the key with this little metallic rope to the cork, and we're going to put it in our jar of water. Now, the hypothesis says that because the key has a heavier density than the cork, and we know that if we put a key, just the key, in the water, it would sink. However, the cork didn't. So let's see if the key helps the wine sinking. So right now our wine cork is our submarine. So it's still not heavy enough. Let's see if we can add more weight. One key wasn't enough. Let's see if we add another key, and it's going to definitely help to sink. Let's see. Submarine, go. There you go. The density of the wine cork has definitely now changed because we added 2 heavier keys to our submarine, and now he can sink. If he wants to float again, he needs to lose the weight and he will float again. Okay, the second experiment we're going to do is that now our submarine is no longer a wine cork, now it's a syringe. Remember, no needle. And to this syringe, we're going to tie a little coin. This time I used a 5-cent coin. So the hypothesis is that in this case, the submarine is completely light and it has no air inside. Why? If I pull the syringe like this, it's going to intake air. However, if we pull it like that, it has no air inside. So because it has no air, the density says, the hypothesis says that because of the heavy coin and the no air inside it, it will sink. Okay, so let's see if the hypothesis is correct. Remember, our submarine is the syringe. We put it in there, it's now in here, and let's see, should it, and it sank to the deep, deep heart of our ocean. Now, this time we want our submarine to float. So what we're going to do is we're going to add air into our syringe. So pull it a little bit. Let's see how much air we needed to sink. Let's put a little bit first. A little bit of air. It's air, no water, okay? And put it again, and let's see if it floats a little. No, it still sank. Let's see, how much air do we need? This time let's add more air. Put it into half. And there you go. Add water inside. And let's put it in there. And this time our submarine is floating. So you see, we changed the density of our submarine by adding air. Okay, time for our third submarine. Our submarine now is the bottle of the little envelope of ketchup, the kind that we receive when we eat in fast food restaurants. And now we're going to use the water bottle or the soda bottle or the bottle you have chosen for this experiment. Remember, you have to have the lid. This time you need to have the water all the way to the top. And this is going to be our submarine now, so he goes straight to the bottle. Make sure to put it in there. Right now, if you see, he's floating. Okay? Let's close the jar. Very, very good. Good. So this time we're not adding air and we're not adding density to our submarine to make it sink. This time our submarine will sink because of the pressure he will receive when we press the water bottle. Okay, so it turns out that the little bottle I had, it was too little and I'm not strong enough. So I'm receiving help, and this is what happens. We press it and our submarine goes down. Can you do it again, please, helper? It goes up, it floats, and it sinks. Okay, I'm gonna try. I know I can do this. I press. Wait, I just did it. I can do this. I press. Yeah!